So first of all, what is DNA Spaces? So DNA Spaces is really Cisco's next generation cloud platform that enables wireless to drive business outcomes. So as you've heard from things like Umbrella or other services, whether it's Duo, Umbrella, WebEx, Cisco's really adopted the fact that the cloud can provide some great features. And something we've always been able to do has been able to show you where devices are located in your network. Like physically, is this in building 1, building 2, is it on floor A or floor B? And that's traditionally been done through a bunch of on-premises equipment, whether that be, very, very long ago, it was called the Location Services Engine, and then it evolved into a Mobility Services Engine, then it's connected mobile experiences. But the latest evolution has occurred after an acquisition a couple of years ago, and we've really been focused on adopting the ability to provide location services at scale. And this is all done through DNA Spaces. And so what we've done today is we have over 1 million access points that are now sending data into our cloud. So just like whether it be Umbrella or WebEx, there's millions and millions of endpoints. As we get into the cloud, the scale really helps us improve our services. We've seen over 500 million mobile devices. Effectively, that means a MAC address where we've been able to determine the location of that. And we've done over 1 trillion location updates. So that's really important to understand how we've been focusing on this scale. The second component of DNA Spaces is it's delivered as a service. So it's something, like we just heard how you can easily turn on Umbrella for your DNS traffic as an inspector. We have really been focusing on how easy it is to enable DNA Spaces to receive data from your controller to offer this as a service. And so we've got this very quick solution where you can, within 30 minutes, activate a customer and start seeing data sent to the cloud. And finally, the third tenet of DNA Space is all about the apps for outcomes, right? So we're developing the solution so that you can build smart applications based on a set of infrastructure that you can depend on. So we can build this, and we have an app store that you can expand location services for. So it's really been 3 evolutions that we've been focusing on. One has been previously APs were always all about connectivity, right? Get packets from a wireless device up through the air into an AP and connect it. And then where we are with most customers now is AP as a sensor. So that AP is not only able to get packets in there for transmitting data, but also understanding RTLS and analytics, where those packets are coming from, where real-time location services can be provided with things like RFID tags. The evolution that we're really focusing on today is that next generation where the AP has a new type of packet it understands. So these are these IoT packets, whether it be Bluetooth low energy packets from a Bluetooth low energy device. We're going to be expanding to Zigbee energy, Thread, other types of IoT devices can now be detected by that same AP infrastructure. So that's the real change that we'll be talking about today. So these changes all based on a couple of phases that we previously talked about, right? So that we've done this indoor location services at scale. So we pushed all those APs so that they're now sending data to the cloud. We then created this infrastructure so that in the cloud, you could add new applications. And what we're talking about today is now that we've got those 2 important things built, we can also enable a new radio on the AP. This is the Indoor IoT Services radio that's on the AP. And so now that we've built the cloud, built the product frameworks, it's really going to be easy to start to add additional services on top of that. And the real focus that we're having there is trying to remove adoption costs of IoT at scale. So there's been all kinds of great solutions, and it's been a wonderful playground of trying Raspberry Pis out with different types of sensors to understand, a temperature sensor in every single room, or a humidity sensor, or occupancy sensors, or location of different types of asset tags. But those solutions have been very hard to scale. And our focus is on delivering a highly scalable, managed way of doing that. So if I have 10,000 sensors in my buildings, similar to the way I'd have 10,000 wireless devices, I need a way to be able to do that at scale and manage that. And instead of having, oh, this sensor is for the people who are doing indoor wayfinding, and this sensor is for the people who are doing another application such as CO2 monitoring, where each of them have their own silo, we're trying to break that over. So let's look at what we're talking about for that. So indoor locations software solution at scale. So we talked about how we got 1 million APs. And so this is actually a dashboard. It's important to understand that we are constantly monitoring this solution. So Similar to WebEx or Duo, where we understand all the entire what's going on throughout the world, we have a solution that we understand location services on a worldwide basis. Phase 2 is where we were talking about delivering different applications. And so the basic architecture to understand is that DNA Spaces receives lots of different data from the controller, whether it be Cisco or Meraki. It receives data from other entities, such as a WebEx T-board, and receive things like static data, like maps from DNA Center. It receives camera data that says, hey, people have crossed this particular camera line. That's all pushed into DNA Spaces and normalized so that we can provide our own GUI dashboards that say, hey, this is the number of people in this building at this time. We can send data to enterprise applications such as SAP or IBM Tririga, or we could send this data as a fire hose, which means we can send a lot of data at a very low cost to different application providers, and they can write applications for the end user based on top of this data. When we combine all that together, that's really the focus of DNA Spaces Cloud. And what's new today that we're talking about for the first time is our Indoor IoT services. So why we created these Indoor IoT services has always been about this fragmented and proprietary walled garden approach, right? So we always thought that there were different Indoor IoT services. This slide is kind of messed up, but whether it be guest experiences, IT departments, they've all had different ways of doing IoT services. And our big switch in DNA Spaces is that regardless of the type of IoT service that you're looking at, we will enable you to have all of this stuff brought in through the DNA Spaces, effectively using your Wi-Fi 6 APs as new types of gateways. So Wi-Fi 6 APs, best in the world for talking 2.4 and 5 gigahertz. For Wi-Fi signals that are modulated Wi-Fi 802.11ac, hey, but what if we also have been included in those Wi-Fi 6 APs, a BLE radio at 802.15n, 15.4 radio that can speak Zigbee, it can speak BLE, it can speak Thread. We're going to be able to turn that radio on. So we'll detect lots and lots of BLE energy or Zigbee energy. We're going to first start with BLE and design an end-to-end solution where you could take BLE asset tags or BLE beacons, be detected by your Catalyst 9100s, normalized by DNA Spaces, and provide that data to lots of different third-party applications. So that's what was going to be happening today. So that's our latest innovation that we're focusing on.
Daryl, if I can and jump in there real quick. So obviously focus is 802.15.4. Is that 2.4 gig only, or is there capabilities also in the 9, 15, 800, and 400 megahertz space?
Great question. So that our particular radios are 2.4 gig only, and so we're very prescriptive in what we're doing inside of the AP. Inside of the AP is an 802.15 and 15.4 radio that can do BLE, Zigbee, Thread, and we are enabling an end-to-end solution first with BLE, and then we're going to use that same infrastructure to be able to do things like Zigbee and Thread at the same level of scale. For other signals, for other types of expansions, we've really been focusing on that USB dongle, so that we have a USB capability and a Docker capability built into the AP. So that's sort of our next generation of additional expansions to other IoT services. So we're building this infrastructure so that we can continue to do this expansion, but the first solution will be based on 2.4 gigahertz, 802.15 and 15.4 solutions.
Thank you.
All right. So this is what's going to be looking like, and so this is going to be something that we're offering as part of our 9800 controllers. With the 9800 controllers, you'll be running 17.3.1 iOS in it. So that's kind of the base infrastructure that we need to get this all going. So that's this step change from APs for years and years and decades had been all about, the greatest 2.4 and the greatest 5 gigahertz with Wi-Fi modulation. Now we're going to also be able to do a two-way handshake with BLE devices to be able to do things like, hey, I need to upgrade the firmware on this particular BLE tag, or I need to tell this particular BLE tag, hey, instead of modulating and sending a beacon out once every 100 milliseconds, I want you to slow down your rate of battery usage and send this beacon out once every 600 milliseconds. That type of two-way communication is inherent in what's possible in our 9000 series Catalyst APs. And then on the other leg, we're not going to just be consuming this data within Cisco. We're going to make this available so different application partners IBM Tririga, Simon AI will all be able to consume these these BLE data that comes over the IoT services pathway. And there's really 4 components that are really important for this. One is an IoT device marketplace. So it's been tough to figure out which which IoT devices you should buy, because there are just so many of them, right? There's so many different BLE devices. There's so many different things that you can connect to a Raspberry Pi to sense different capabilities. So Cisco's going to try to make this easier for our enterprise customers. So we'll have an open IoT device marketplace that provides some choice. So it's not going to be just one brand. Some of our competitors just have their particular BLE devices. We're going to say, no, you can buy BLE devices from a variety of different vendors. We'll have deep links into those vendors to make sure that they're validated solutions. And then the second part is we'll have the DNA Spaces App Center, where we'll say, yeah, we're also not going to be able to provide all the end-to-end apps by ourselves. We're going to provide an app store that says, hey, I want to be able to buy an application from Simon AI that uses my asset tags, buy an application from IBM Tririga that uses proximity sensors. We can build these applications independent of the devices. But the 2 components that Cisco will be delivering, and that will be very important to this, is that Wi-Fi 6 AP with dynamic gateways. Why we say dynamic gateways is that we're going to be using the Docker image that's inside of an AP to be able to control that 802.15.4 radio. So you'll have your regular AP image, and you'll have this Docker that's also running that can be upgraded independently. So we can provide additional 802.15 BLE services when your AP is still running 100 miles per hour servicing traffic. So it really allows that additional flexibility. And then finally, this is all going to be done by a cloud-managed IoT device management. So we're going to be focusing on something that's going to be simple to use. The actual packets that come off APs are gRPC packets that come to a connector, and then they're processed in the cloud. So most of the configuration and additional dynamic work will be done in the cloud.
Can I ask a question on that? So
sure.
just so I'm understanding right, are the vendors who are creating the IoT devices, do they have to use the APIs in order to run through this unified system? Do they have to use your APIs in order to be able to program through that and access their devices through the Catalyst APs?
A good question. So we agree on a set of APIs, so that we're not saying they have to use ours. We provided some samples. So we are working with companies like Contact, Aristaflow, Minu, Stanley. And so no, we'll change and adopt to their particular variations. They just have to tell us what they need. So that's how we're building up this ecosystem that we will provide some examples. So for example, we will immediately on launch be able to read the asset tag profile from Contacts and Minus and Stanleys. But as other companies come to us and say, oh, in byte 17 and 18, this is where I like to put this particular information. We're like, okay, great. We'll change our parser because we have this dynamic gateway. Now this system will flow end to end. So we are not imposing this on the industry. We're really adapting to what's going to be coming out of the IoT device markets.
Right, because and this is something, and I realize this is pushing it slightly because you're Cisco, because this is been the huge IoT problem is 1,000 standards, not just at the physical layer and the Bluetooth layer for the devices themselves, but also 1,000 communication standards in terms of protocols that they want to use. And what would be fantastic is we start getting some kind of API that's it's not just the Cisco APs that are starting to come with BLE in them, right? There's other APs from other vendors we won't mention, and it would be lovely ultimately if you guys were driving that kind of API across the industry, where we started to see all the vendors were really keen on developing for it because they saw adoption as a benefit to them, because yes, there's this huge installed Cisco base, and there's a fringe benefit that some of the other vendors, they're going to get a sales through that too. And then it's in their interest not to have to develop for 5 different APIs again, because in addition to all of their own standards, now they've got to develop for all the other vendors too, right?
Absolutely. So we really do believe that there's a sea change that needs to happen in this industry, kind of like what you're talking about, to really open it up, right? all these micro solutions have been great for POCs and trials, but as you start to say, I need 10,000 sensors and I can't have a full-time person managing them, how am I going to do that? And so that's really been our focus, is we are going to say your APs will be this infrastructure. We're going to have a validated device marketplace, but we're not imposing that says, oh, there's this Cisco proprietary standard you need to follow. We're going to say, come to us, Mr. BLE beacon vendor, and we'll try to work with you to come up with the standards. We've already worked with several different vendors to do that. And again, if the vendors work with other companies, I think that'd be great too for the industry. I think they should work with Cisco though.
I'm assuming they will.
I hope so.
Thank you.
Right. So that part of that, that first part of that is that, of course, installing dynamic gateways. So, if you really wanted to do an IoT overlay system, why it would take weeks or months is because I need to get approvals. I need to design the solution, what it's going to look like in my ceiling. I need to drill new holes. If I wanted to put an overlay BLE sensing solution, it could take weeks or months. But imagine if you have these 9100 APs already mounted, now I can just say, yeah, push this Docker image into the AP, and all of a sudden I have a BLE gateway in my entire network. And you can instantly start streaming this data. The second thing we're really focusing on is scale. So because we have solved a lot of these problems that scale through APs and devices, we will know how to do this really for IoT, right? So that we know how to connect to 1,000 or 10,000 APs through our controllers on our infrastructure. We're taking that expertise and expanding it to our IoT. Third, we're really thinking that as we've done the models, that's going to reduce your total cost of ownership because you're not installing overlay BLE or overlay IoT device sensors. You can use your existing APs, and the cost of the individual devices, because they're no longer wrapped into this, oh, you're going to buy a device and a gateway and an application from the same vendor. You can start to buy best of breed hardware from really great manufacturers, and then best of breed software for really great software makers. And then finally, we're focusing on maintaining and monitoring these performance of these devices end to end so that they can be proven to work, right? Because many of these IoT services work great when there's a champion, right? When there's one guy who's really interested in making sure the system's always up, but that person either changes or there's there needs to scale, that solution kind of loses focus. What the switch on this one is, Cisco will be actively monitoring these devices, making sure the devices are up, they're going to return a service level agreement. If the device is supposed to be beaconing out once every minute and it's not, we're going to be able to mark those types of devices. So we're going to be focusing much more on that end-to-end performance. And we really think that these are at least 6 different outcomes that we're going to be enabling across industries, whether it be asset management, which is one of the really big ones. There's lots of different types of asset tags that you can put on devices. As Wi-Fi devices start to have different MAC addresses that aren't always the same, you're going to need something with a consistent identifier, which can be a MAC address or other type of unique ID, device ID, that you'll be able to attach to a physical device and constantly be able to know where that device is. Room finding and employee safety. Employee safety is especially important now in the days of getting back to work post-COVID. A BLE-based tag around the neck of an employee could be a great solution that we've got enabled in our end-to-end solution. Space utilization and environmental monitoring, again, continue to be really important. Being able to do CO2 monitoring or airflow monitoring, but not in a small trial solution, at a solution where you've done this at scale with tens of thousands of devices monitoring your network. And what we really find is that the solution on this has resulted in a 3x reduction in the total cost of ownership. As we've done this model with other customers, we've found that they have a lot less day 2 support, a lot less money being spent on their BLE gateway and their BLE software management, because this is already embedded into the APs that they have already existing. So let's take a little bit look at how this actually works. So DNA spaces, you would start with setting up the DNA spaces in the AP gateways. And so these gateways have an install process, which is what we call a quick start guide. So it actually tells you why I want to install the on-premises gateway. Then the next big focus is you enter information about your maps and location hierarchy, because it's really important to describe correctly where devices are. You put that all in the maps and the location hierarchy that says, hey, this location hierarchy of a building, a country, city, building, individual meeting room, you're going to describe all the metadata that needs to occur on those ones, so that when I want to know where an asset is, I have a vocabulary that's consistent across all of my apps. So whether it be a HVAC app saying, hey, what's the temperature in this room, or an asset tracking app that says, hey, where is this asset? Both of them would have the same definition of that exact room. We enable those Wi-Fi 6 APs, and we'll talk about how easy that is. So that's just a matter of saying, hey, I want to add a gateway. And so we have this new left-hand side navigation with IoT, where we'll select an AP gateway. We'll add gateways. We'll say, hey, let's get started on adding this gateway. We can say that this gateway is going to be, what Docker image are we loading in this gateway, in this case, BLE. We can select what particular areas we want to load those gateways in. And then we can say, hey, let's enable that BLE functionality to all of those. So now we have, of all of our 6,000 or 7,000 or 8,000 APs, we can show that these 6,000 have advanced functionalities and these ones have base functionalities from the BLE. So this is how easy we're going to be focusing on pushing a new function to existing APs by using deploying a Docker image onto those APs that have this BLE gateway functionality. The next focus after that is on the end device marketplace. So you were a little bit talking about the different devices. And so this is an example of some of our device stores. So let's say you wanted to order an asset tag. Cisco's not going to participate in this revenue stream, but we're going to provide a deep link to a validated asset tag that says, oh, the contact S18-3 beacon is one that we understand. We can provide this end-to-end flow to anybody. So you could use that asset tag on any application that you build, and you'll know with confidence what data it goes, how to parse it. That will be the focus that Cisco will be able to do. So you can check out with that asset tag, and we'll just give you a recommended list of these tags that you might want to look at. Next, after you've got those asset tags, we need to be able to claim those inside of the DNA Spaces space. So you've ordered these independently, but you need to be able to go in the DNA Space and say, oh, these tags that I've ordered, I want to onboard them. So I'll know that I go to a particular asset tag. I then have a deep link into the manufacturer. So whether this be Contact or Minu or Centrax or Stanley, we'll be able to say, oh, these are the tags that belong to them. Let's onboard them to my customer. So that it says, oh, those tags are asset tags, those tags are temperature tags that we've attached to particular refrigerators. I can start to do that at scale by just selecting onboarding these individual tags, onboard them, and getting the invoice number. So we're trying to make this as easy as Meraki as you start to onboard new APs into a Meraki where you just put the order number and they get claimed. That's the process that we've been focusing on for claiming these IoT devices. The next step is, after you've claimed the devices, is to configure them. So the configuring of the devices really comes off in the ability to use this what's called End Device Lifecycle Manager. And so all the configuration of the devices, that may not be done on Cisco end-to-end. We may just be able to configure some of the values, and we work with some of the partners to say what other components need to be configured. So for example, if we wanted to configure the transmit level, we can go in and work with our partner to say, oh, to send the transmit level for this particular tag to this value, we go in through this and do this type of configuration. In this case, I select the tags, select that, hey, these are the devices that I want to compatibly configure, and this is the change I want to make. So that when you're making these changes, you're no longer tied just to particular devices. You can make these changes across your entire set of onboarded devices. And finally, the last step is to activate the applications. So these applications are the ones where, now that I've got this great set of data, which is continuous temperature monitoring on thousands of asset tags, I want to maybe send this data to different application vendors. And so we've got this whole app store of different application vendors. So whether it be Aristaflow in the hospitality space, MazeMap that does great indoor wayfinding, or grabs data from a WebEx team board and tells you whether or not a device is active, you can grab all that data and put it through different applications. And how that is done is what's called the Firehose API. So we've built the system so that the individual application vendors can pull data from a Firehose API. So they pull data from an API that is, they get one stream from Cisco with different customers in that stream. So every time they implement a new customer, we just tell them about the new customer and they can pull that data. So this is a very consistent, what we call Firehose API. And it's different than the traditional REST response request API because it's a long pole HTTP streaming API. This is kind of how Twitter and other very high scale solutions work, because they say, you make a request to me and then I will constantly send you updated data. The older way of constantly sending the updated data was webhooks, right? Where you'd establish a TCP connection, send data, close the connection, and then start again. That is not as efficient as the streaming API that we're going to be focusing on, where you make this request and then we send you data. And then if we've got no data to send, we send you a keep alive. So we keep this one HTTP session alive for a very long time, and you continuously send additional data. So you'll know a device has entered, a device has exited, a new temperature reading has been detected. So all of that done on the streaming API allows you to have a much more advanced solution for your individual application providers. So they're able to scale, and we're able to scale more quickly also. And then finally, because we have this connection to individual application providers, we can provide monitoring and support. And what that monitoring and support looks like is we understand which devices are activated, and which devices are returning responses. So when we look at our dashboard, we can say these BLE devices had been last heard at this particular time. We can say, are these devices behaving the way they're supposed to? So finally, let's take a look at how that works. All right, so for the last couple minutes, I'm just going to actually go into a demo. So I went down to this new IoT services here on the left, the new device inventory that we're looking at. I'm sharing your screen share, yeah. You should be seeing that. I looked at floor beacons. From the floor beacons, I looked at my individual house. So right there is all of the individual floor beacons that are seen right now at 11:22 p.m. PST. I'm seeing in my house right now. These are beacons that are currently being seen by my Mindy 120, as well as both iBeacon protocols and Contact IO, which is another protocol coming off of a beacon, which is a BLE sending 802.15.4 over-the-air signals in a particular encrypted in a particular method. In this case, they're in a Contact IO profile. And so when we click on that individual beacon, we're able to say, oh, what information am I seeing? In which case I'm seeing this particular beacon has a battery that's at 83%, its temperature is 22. I can get the information on movements and when a double tap was last done on these. So all of this parsed information is what comes off of floor beacons. So this is really the new capabilities that now exist in DNA spaces. And so it's really important to note that this is all off of what we call AP beacons in scan mode. So I'm going to look at an individual beacon. So in this case, this is, I can show you that I've got a 9120. In this case, I've got, I'm showing my floor beacon is scanning. It's a 9120 with a particular MAC address. So it's, time is heard right now. And this beacon is scanning with its new BLE radio. In this case, when in settings, you'll actually look, it's in BLE mode scan. So you'll be putting that fourth radio in the 9120. So you've got your regular 2.4 serving radio, your 5 serving radio, your DFS radio for off-channel scanning, and its fourth BLE radio. This is now the control point for it. So it's really exciting that we're now controlling that fourth radio. So this fourth radio I'm putting into BLE scan mode for this. And this is on the 17.3 software. So 17.3.1, which will be coming in August of this year, is now how I'll be able to enable this new functionality. So excited. And then what do I see from those new BLE radios? I can scan lots of different beacons, in which case, just in my house, I detected about 17 different beacons, right? And some of the ones that I am detecting are including all the different iBeacons that I'm seeing in my house with the different majors and minors, as well as the ability to see different sensors. And so the sensor information is coming across as a BLE beacon advertisement packet. This advertisement packet is then parsed through my DNA spaces, and it can be provided to different applications. And so that's the end-to-end solution that works. And then so now that I know, great, I now have a really cool way of understanding this BLE battery, this BLE sensor is detecting a 21 degrees temperature. Well, what can I do with that? That's really the next set of applications. And so that's where in DNA Spaces, we have two ways of using that. One is this own extend functionality, which is an app store that allows you to create different applications, right? So we've got demo application experience from Contact. We've got the ability to do a BLE skimmer detection. So it's a really interesting application I'm working on to be able to detect why somebody is, using a BLE as a credit card skimmer. But our whole set of partner applications are available, right? And so these partner applications come with the partner originally creating it. We vet the application through initial demonstration, and then we put this into the App Store, similar to the app model, or similar to the Apple model, or the Google model, or the and so you've bought of applications. But let's show you one of the basic applications that we have at Cisco. So one of the basic applications is our asset locator application. In our asset locator application, we can see that wonderful BLE asset tag and be able to provide some basic visualization. In this case, I've got that asset tag that had that temperature. So I'm going to click on that, and we can actually say, well, this is the BLE, wonderful BLE asset tag, which was completely new, that wasn't be able to detect it before. Now I can show you where that BLE temperature tag is within my office, right? So it's in the main zone of my office, right? And so it says it's been located in my home floor 1 main zone, which is the located zone here. And we've got some history that will be able to show, well, what are some of the telemetry data that's coming off of that tag? In which case, I'm really kind of looking at the temperature. And so you can see it's been a nice, constant, cool 21 degrees in my office all day, as we want to expect. But this is just a small example of what's possible with these new different asset tags. The overall end-to-end architecture has been built so this can scale out to really dramatically. We've got a map view or a list view of these individual asset tags. As we look at, just on my floor, I can see I've onboarded, 3 different tags. And so I can see all the different types of tags that are on my floor, a moving asset tag, a temperature tag, different tags that are sending different types of telemetry. But the important thing to note is this asset locator is sort of Cisco's sample version or basic version of an application that is included as part of our app store. But this same level of detail can be used to build your own apps or to build or off of commercial applications. So all the data that comes off of our IoT services, device inventory, where we can see millions of different floor beacons. I can filter the floor beacons in a different way. In this case, I'm filtering out my house, seeing all of these different floor beacons, all of this telemetry information, which is coming in real time. I am able to parse this and send this up to different applications. And so that's the real focus of Cisco's new IoT services.
There looks like there's a lot of location information that has to be in the system before you can actually get to the kind of usability that you're demonstrating to us. Things like where is, beacon 1, where is beacon 2, all of that. Is that something that has to be manually inputted, or are there automation tools or other tools that make inputting that location information easier?
Great question. So the first place that all of this information is based on is maps created in DNA Center for modern maps and Prime for more traditional maps. So in that place, that's where you're going to pull down the JPEG image of a floor and then drag the individual APs onto that map. That becomes the source of truth for the rest of the layers. So that's the first tool that you're going to be using is Prime or DNA Center to place APs on maps. Once those APs are placed on the maps and the metadata, it's like things like, what's the square footage of this particular floor? What's the occupancy values? So you put those things on the map, you add some, we call that metadata. That metadata can be imported with things like a CSV export. And so you would know building 1 has an occupancy of 400 people, put in a big spreadsheet, update that in the DNA Spaces as an automation tool. But that's the basis that you start on. Good maps, built-in Prime or DNA Center that know the location of the APs, and then all of your applications can take advantage of them.